Welcome to the DIY Honda Garage channel. The Honda Pilot models from 2016 to 2022 may exhibit a Diagnostic Trouble Code, DTC P0193, which stands for Fuel Rail Pressure Sensor Circuit High Voltage. This code indicates that the engine control module, ECM, is reading an unusually high voltage signal from the fuel rail pressure sensor. The fuel rail pressure sensor is a crucial component that monitors the fuel pressure within the fuel rail, helping to optimize combustion and overall engine performance. It's typically located along the fuel rail, which is situated on or near the engine itself. It connects to the ECM, which uses the data to manage fuel injection and adjust engine timing. Diagnosing this code involves ensuring that the input voltage from the sensor is within specified limits and checking associated wiring for faults or continuity issues. The fuel rail pressure sensor plays a vital role in modern fuel injection systems. It continuously monitors the pressure of the fuel within the rail, which is necessary for precise fuel delivery and optimal engine performance. Located directly on or very close to the fuel rail, this sensor helps the engine control module, ECM, to adjust fuel injection timing and volume based on current engine demands. By providing real-time data about fuel pressure, it enables the vehicle to run efficiently under various loads and speeds. If the signal from this sensor indicates a high voltage, as seen in DTC P0193, it suggests either a malfunctioning sensor or an electrical issue in the circuit. Addressing this DTC promptly can prevent further engine performance issues and ensure reliable vehicle operation. There are several possible causes for DTC P0193. One common issue is a faulty fuel rail pressure sensor itself. If the sensor is defective, it may send an incorrect voltage signal to the ECM, triggering the high voltage DTC. Additionally, wiring issues can also contribute to this code. Damaged, frayed, or shorted wiring could lead to voltage readings that fall outside the normal operating range. Poor connections at the sensor or between the sensor and the ECM can also create high resistance or interruptions in signal transmission. Lastly, a malfunctioning engine control module, ECM, could falsely interpret the signals received from the sensor. A thorough inspection of the sensor, wiring, and connectors, as well as the ECM, is essential to pinpoint the exact issue. When DTC P0193 is triggered, you may observe several symptoms related to engine performance. One of the most noticeable signs is a check engine light appearing on the dashboard, alerting you to the malfunction. The engine may experience performance issues such as rough idling or stalling, making it challenging to maintain speed or power during acceleration. Additionally, drivers may find that their vehicle has difficulty starting, signaling potential fuel delivery problems. Furthermore, because the fuel rail pressure sensor works closely with fuel injection systems, you may experience decreased fuel efficiency as the engine struggles to attain optimal combustion parameters. These symptoms necessitate immediate attention to prevent further complications. The first step in troubleshooting DTC P0193 involves verifying the problem through a systematic approach. Start by turning the ignition key to the on position without starting the engine, and wait for at least 2 seconds. This allows the onboard diagnostic system to establish baseline parameters. Using the Honda Diagnostic System, HDS, check the input voltage coming from the fuel rail pressure, PF, sensor. The diagnostic threshold here is more than 4.89 volts. If the current conditions match this threshold, it indicates that the failure is confirmed, and you should move on to the next troubleshooting step. However, if the testing shows no matching conditions, then it could indicate an intermittent failure, at which point you should inspect for loose terminals or poor connections. In the second troubleshooting step, you will determine the possible failure area related to the fuel rail pressure sensor. Begin by turning the vehicle to the off or lock position. Next, disconnect the 3P connector from the fuel rail pressure sensor. This step isolates the sensor from the circuit. Using a jumper wire, connect terminals A and B of the fuel rail pressure sensor connector. Terminal A corresponds to connector number 1, while terminal B to number 2. After making these connections, turn the ignition to the on position once again. At this point, you will once again need to check the input voltage using the HDS. The expected reading should again be more than 4.89 volts. If it matches, you will proceed to the next step. If not, you may need to replace the fuel rail or the sensor itself. Moving to step 3. This part of the troubleshooting process is focused on determining the condition of the SG1 line and related components. As before, turn the vehicle to the off or lock position, and then remove the jumper wire you previously connected to the fuel rail pressure sensor 3P connector. Now, turn the vehicle ignition back to the on position, while ensuring the fuel rail pressure sensor 3P connector remains disconnected. The next step is to measure the voltage between test points 1 and 2 carefully. Test point 1 refers to fuel rail pressure sensor connector number 2, and test point 2 refers to connector number 3. You should see a voltage reading of approximately 5.0 volts. If this condition holds true, the SG1 wire is functioning correctly, and you can move forward in the troubleshooting guide. If the voltage is off, it may indicate an issue with this specific wire. In the fourth troubleshooting step, focus shifts to inspecting the PF line for continuity. Begin by turning the vehicle to the off or lock position. Utilize the HDS to jump the short circuit SCS line and wait for a minimum of 1 minute for complete operation. Following this, disconnect the 51P connector associated with the Powertrain Control Module, PCM. You will now check for continuity between 2 designated test points. Test point 1 is defined as the fuel rail pressure sensor 3P connector number 1, and test point 2 represents the PCM connector B35 line. Verify using a multimeter whether you have continuity between these points. If continuity is present, it indicates that the PF wire is fine. However, if there is no continuity, you will need to repair the open wire that connects the fuel rail pressure sensor to the PCM. The fifth and final step in troubleshooting involves checking the SG1 line for continuity. Just as in the previous steps, start by turning the vehicle to the off or lock position. Again, utilize the HDS to jump the SCS line and wait for at least 1 minute. Following this procedure, disconnect the 51P connector from PCM-C. You will then check for continuity between 2 new designated test points. Test point 1 is defined as the fuel rail pressure sensor 3P connector number 2, and test point 2 signifies the PCM connector C33 line. With a multimeter, check for continuity between these points. If continuity exists, the SG1 wire is unobstructed, and you may wish to consult any available service reports related to DTCs. Should there be no continuity detected, you will need to repair any open wire issues between the PCM and the fuel rail pressure sensor, ensuring a solid electrical connection for proper function. Once you've completed all troubleshooting steps for DTC P0193, it is essential to perform a final repair verification. Start by rechecking all the connections made throughout the repair process to ensure they are secure and free from damage. Next, utilize the HDS to clear any previously stored DTCs, which allows you to reset the monitoring system. After ensuring everything is secure, conduct a road test to verify that the vehicle operates normally and that no check engine lights illuminate during the drive. It is important to monitor the vehicle under varied driving conditions to assure that all systems function correctly. If the DTC reappears, further diagnosis may be required to explore more profound issues with the PCM or other components related to fuel pressure monitoring and management. Preventive maintenance is crucial to avoid issues related to DTC P0193 in the future. Regularly inspecting the wiring associated with the fuel rail pressure sensor can help identify any potential issues before they arise, such as fraying or corrosion. It is also advisable to periodically test the sensors for consistent performance, ensuring they remain within specified operational parameters. Keeping all electrical connectors clean and free from corrosion will minimize resistance and ensure reliable data transmission to the engine control module. Additionally, if the vehicle is frequently operated in harsh environments, consider taking special care to protect both the wiring and the sensors from wear and exposure to extreme conditions. Implementing these preventive measures can significantly extend the lifespan of your vehicle's fuel system components. In conclusion, DTC P0193 indicates a high voltage signal from the fuel rail pressure sensor and can lead to significant engine performance issues if left unaddressed. Following a structured troubleshooting process can help accurately isolate and repair the problem, whether it be the sensor, wiring, or the engine control module itself. It's vital to verify your repairs thoroughly through proper testing and road testing the vehicle to ensure proper function. Additionally, implementing proactive preventive maintenance will help mitigate the risk of encountering this issue again in the future. Overall, tackling DTC P0193 in a timely and efficient manner can improve not only your Honda Pilot's performance, but also its overall reliability. Please like and subscribe to the channel. See you next time.